Hello and welcome. This is Columbia Basin Research's fourth video in a multi-part series on using Program Basin TribPit. BasinTribPit is a program created by Columbia Basin Research at the University of Washington's School of Aquatic and Fishery Sciences with funding provided by the Bonneville Power Administration. Program Basin TribPit's main purpose is to provide cohort-based survival estimates that account for the possibility of an individual fish overwintering for one or more years or migration periods during the downstream migration process. In the first three videos in this series, we demonstrated getting the program running, loading the necessary data files, reviewing the parameters of BasinTribPit models, and running through configuring the program itself. Today, in this fourth video, we're going to go over the results generated by the program. First, let's fire up the program. Now again, video 1 in this series dealt with our data files here, and video 3 with our various configuration options here. If you are not familiar with those, please watch those videos in this series. If you want to follow along with this video, it is recommended that you have the practice observations and age data files loaded in. When you load in the age and observations files, you may find that there is extraneous data that may affect model choices and could even cause a program to error in fitting a model to your data. It is worth your time to go through the observations data to assure it fits your expectations before you fit the models. If not, you may find that fit all models errors occur when processing the data, as shown here. Video 3 in this series covered some of the things you can do to properly sort your observations data. Video 5 will cover some of the more unique instances that you may need to sort through. After you've sorted through the issues raised in those videos, you should be able to click Fit All Models without error. After the program has fit all models, a second window opens with the modeling results. There are a number of reports that are provided. We will look at each of these shortly. First, let us look at the navigation panel here, where you can see summary results, showing results across multiple models and weighted performance measures, graphical results, showing the parameter estimates graphically, and model-specific reports, showing the parameter estimates for the optimal model or any of the suboptimal models if desired. In all the reports, the point estimates are followed by their standard errors in parentheses. There are two buttons in the bottom of each report here, Print to print the report, and Save as CSV to save the report in comma separated value format. Under the Summary Results heading, there are two reports that the user may select. The Model Comparison report appears when the data is first fit, and if available, the Weighted Performance Measures report. Let's first look at the Model Comparison report. This report provides a comparison of all the models that BasinTribPit attempted to fit. The models range over the different combinations of parameters that are equated or unique, from model MYS1, in which all capture parameters and all survival and movement parameters are unique across all release sites and release years, to model MYS9, in which all capture probabilities are equated across release sites and release years, and all survival and movement probabilities are also equated across release sites and release years. The report has 4 columns. First, a description of the model, including the model ID and a full description. Second column, the Delta Akaike's information criterion, AIC. The optimal model, the model with the lowest AIC, is assigned a Delta AIC of 0 and is highlighted in bold and blue. For all other models, the Delta AIC is calculated as the AIC of the model minus the AIC of the optimal model. Column number 3, the number of parameters in the model, and column number 4, the log likelihood value. The models are arranged in a hierarchical manner. Each heading describes a parameterization of the capture parameters. All models under a heading use the same parameterization of the capture probabilities and different parameterization of survival and movement probabilities. For our example dataset, the optimal model is MYS9, in which all capture probabilities are equated across release sites and years, and all survival and movement parameters are also equated across release sites and years. The Delta AIC values indicate that there is also some support for some of the other models, especially for MYS5 and MYS8, which have very low Delta AIC values. There is the least support for the models MYS2 and MYS3. Their Delta AIC values are noticeably larger than for other models, which indicates that they are not well supported by the data. The Weighted Performance Measures report mirrors the Model-Specific Performance Measures report. It is only available if there is at least one suboptimal model with a Delta AIC of less than 10. The estimates of the Weighted Performance report are model-weighted estimates from the optimal model and all suboptimal models with a Delta AIC less than 10. The model weights are computed using the AIC values, and the model with the smaller AIC values are given higher weights. See the manual for more detail on how the Weighted Performance Measures are computed. Graphical results displays the survival and movement parameter estimates on graphs for each release that correspond to the graphs used during model configuration. The user clicks on the release name to show the results graphically for that release. Here you can see Chihuahua 2010. If the user puts the mouse over a result, the corresponding estimates at the bottom will be highlighted in gray. Here you can see the mouse over the estimates for release to MWE. The highlighted row at the bottom shows the estimate of 0.7292 had a standard error of 0.0460. There are also 3 model-specific reports under the header Model-Specific Reports in the navigation panel: performance measures, survival and movement estimates, and capture parameter estimates. Each report name is prefaced by the model ID of the optimal model. When the user clicks on one of these reports, the report for the optimal model is displayed. In order to view a report for a suboptimal model, click on the small arrow to the left of the desired report type. Here you can see I've clicked on the arrow for MYS1 performance measures. Notice that all the standard errors for this model are given as NA. These NA values indicate that the model did not fit properly. This tends to happen when the data are too sparse for the model. In this case, model MYS1 is the most complex model considered. It uses unique parameters for all release sites and release years, and apparently it is too complex for the data. Although BasinTribPit shows you the results for this model, you should not rely on these results because the standard errors are NA. We can see the performance measures report for any of the models. Each of the 3 model-specific reports have a header in common. The header lists number 1, the name of the primary releases, number 2, the name of the auxiliary releases, number 3, the model ID, number 4, a description of the model, number 5, the number of model parameters, number 6, the log likelihood, and number 7, the Kaike Information Criterion, AIC. The performance measures report seen here provides the user with estimates for a number of performance measures. First is the overall cohort survival, which is the survival probability from release to the site furthest downstream for which survival is estimable for each of the primary releases. By default, that site will be the penultimate site. The cohort survival by site location is the survival probability from release to each downstream site, first for the primary releases and then the auxiliary releases. The age composition of migrants by site is the proportion of each age class at each detection site for each primary release. The downriver survivals below residualization is the survival from the last site for which there is residualization or overwintering to each subsequent downstream site for each primary and auxiliary release. This is available only if there are at least 2 downstream detection sites below the last residualization site. In this case, this is survival from MCN to JDA. Notice that there are year-specific estimates because some fish from the release group arrived at MCN in 2010 and others arrived in 2011. The details of the calculations for the parameter estimates report can be found in Appendix C of the user manual. The survival and movement parameter estimates report seen here provides the estimate and standard error for all estimable survival and movement parameters for each release. These are the beta and phi parameters that were introduced in video number 2. You can think of them as transition probabilities. They are combined to give the cohort survival probabilities reported on the first 2 reports we looked at. These are the same estimates that are provided on the graphical reports. Notice that they are reported for both different reaches and different time periods. For the first release, Chihuahua 2010, we have estimates from the release site to MWE for fish leaving the release in 2010 and arriving at MWE in either 2010 or 2011, and estimates from MWE to MCN for fish leaving MWE in either 2010 or 2011 and arriving at MCN in 2011. The capture parameter estimates report lists the estimates and standard errors for all estimable capture parameters for each release. The capture parameters are the conditional probabilities of detection or capture given that the fish is present at the detection site. Some call these detection efficiencies. Very low capture parameters can result in high and imprecise survival and movement probabilities. We can see here that the capture probabilities for MWE in 2011 were pretty low. That's the basic overview of the various BasinTribPit results and reports generated by fitting the various models to your data. We'll go into some of the stranger cases in the final video in this series. This has been Lesson 4 on using Program Basin TribPit, in which we looked at your Basin TribPit results and the various reports generated by the program. The final video in the series, Video 5, will offer some further tips on getting the most out of the program. If you are using Program Basin TribPit and you have any questions or comments, you can fill out our satisfaction survey as mentioned in the YouTube notes. We would greatly appreciate any feedback you have in helping make future versions of this program to be more helpful to our users. We hope that this video helps you get the most out of Program Basin TribPit. Again, if you have any questions or comments in regard to the program, please fill out our survey as previously detailed. You can also contact Columbia Basin Research at web@cbr.washington.edu. Best of luck with your survival models, and thank you.